For the past 3 decades, value creation has been locked inside screens. We mastered the economy of bits, writing software, distributing media, and moving digital information at light speed. Now, the target has shifted outward. We are crossing into a $100 trillion economy of atoms, attempting to automate heavy industries like manufacturing, agriculture, and global transportation. The engine for this shift is physical AI, artificial intelligence built with spatial awareness, physics comprehension, and robotic embodiment. Algorithms are escaping the digital realm, remapping the logic of how we build and move tangible goods. Corporations are aggressively pursuing this transition, pouring billions into autonomous gigafactories, sprawling robotics labs, and highly automated hardware production lines. Trillion-dollar investments have successfully addressed the initial hurdles of raw computing power and massive datasets. The limitation is now human capital. A systemic shortage of specialized educators and engineers has left these facilities without the experts needed to program and maintain them. This environment demands a completely different profile of worker. We need orchestrators, people trained to analyze synthetic data and supervise networks of autonomous systems rather than execute repetitive physical tasks. We have engineered the ultimate automated tools. We simply lack the human workforce required to switch them on. Fixing this requires a massive update to our educational pipeline, creating a train-the-trainer dilemma. Schools have to somehow teach simulation architecture and hardware-in-the-loop engineering, where software directly interacts with physical machine parts in real time. The problem is economic gravity. Academia operates on fixed budgets and cannot offer the salaries necessary to poach top-tier robotics experts away from tech conglomerates. The fix is a hybrid educator model. Universities will rely on industry professionals from tech giants acting as professors of practice. Concurrently, existing faculty need aggressive upskilling to adapt curriculums to physical AI. A traditional mechanical engineering or physics teacher can no longer rely purely on classical formulas. They have to learn exactly how modern neural networks interpret and predict fluid dynamics inside a simulation. This technology evolves month to month, rendering standard textbook publishing cycles obsolete. For students to learn relevant skills, tech companies will have to physically embed their own hardware, software, and human trainers directly into community colleges. Because autonomous systems operate 24/7 without fatigue or human error, the marginal cost of physical labor begins to collapse. While raw materials and energy still carry a price, the cost of the work itself drops toward zero. Look at the last 50 years of global trade. The defining strategy for advanced economies has been outsourcing manufacturing to regions with a massive supply of cheap human labor. Physical AI erases that geographic advantage. A robotic facility in Ohio that designs, simulates, and manufactures goods around the clock will undercut a human-operated factory abroad on speed and price. Advanced economies will reshore their manufacturing bases. This withdrawal of capital will severely damage developing nations that have historically relied on exporting low-cost labor to survive. Labor will cease to be a physical human export. It becomes localized, autonomous orchestration, rewriting the mechanics of global trade. Control over simulation software and advanced actuators has become a primary lever of global power. Whoever builds the workforce to support these systems first will dominate the physical economy. Because training these models requires massive computational infrastructure, a handful of megacorporations and superpowers are positioned to monopolize production and defense. The stakes attached to this monopoly are incredibly high. When digital AI fails, a computer screen glitches. When physical AI fails, autonomous vehicles crash and heavy industrial arms injure workers. Deploying under-tested physical models is lethal. The global community will be forced to establish rigorous, standardized regulatory bodies, acting much like the FAA does for aviation, to certify these systems before they enter human environments. A robust domestic pipeline of systems engineers has become a mandatory requirement for national security. This transition will trigger a painful period of societal disruption. We are looking at a great displacement, where millions of traditional blue-collar jobs in warehousing, long-haul trucking, and assembly lines will be automated out of existence. To manage the pressure of millions suddenly losing their income, governments will face intense demands for retraining subsidies, universal basic income, and heavily shortened work weeks. As physical labor is handed over to machines, we face an existential cultural challenge. society will have to collectively redefine what actually constitutes valuable human work. We will likely place a new societal premium on hyperhuman traits, abstract creativity, complex empathy, and strategic leadership. Automating the physical world promises incredible abundance, but only the nations that commit the capital to restructure their education systems today will have the workforce needed to actually build that future.